Well, good evening, everybody. Welcome to our second of a three-part series on construction estimating series. We are so proud and blessed to have, again, Hoffman Construction providing the valuable content that you're going to learn today on structural estimating. I'm going to do a little housekeeping for those folks that are actually here present. Our bathrooms are down the hallway to the left of the elevator. And this building is a COVID compliant building. Everyone coming into our facilities, temperatures are taken, and we are taking all the, we're trying to be as diligent as we can to keep everyone safe and healthy. Today, we're going to hear from our speakers, as you can see. Today, our primary instructor is going to be this handsome gentleman to my right, Chris, and he will be delivering the presentation today. Our class agenda is as follows. We're going to be doing our introductions of our panelists, set up our class objectives, go through primary structural systems, secondary systems. We're going to go through a practice takeoff series where we can actually go through the process of developing a takeoff, as well as going over price considerations, questions, and upon conclusion we'll be discussing upcoming opportunities as well. Also, I wanted to let you know that this class, like the other class and the three-part series, all are being videotaped. As you can, some of you that are watching online, you may not know, but we actually have a number of devices that are delivering this content live. We're going to take this content, we're going to edit it down and provide a more polished view. So those of you that are here, you're going to experience this live, but those of you who are not, you're going to see a more condensed version of this. I'm going to begin by introducing myself. Again, I'm Dan Seydel. I'm fortunate to be the founder of the Entrepreneurial Institute of Washington. I've been working in business and government contracting for over 30 years. Today we are blessed to have an executive with Hoffman here, Dave Johnson. And so Dave has been just a tremendous asset to the Entrepreneurial Institute of Washington, as well as our many members and followers. He has provided hands-on mentorship to these firms and really has elevated the visibility and the capacity of firms across the state. Let's give a warm welcome to Dave Johnson.
Thanks, Dan. Appreciate the opportunity to put on a set of presentations like this, and we like to figure out how we can help build capacity and build relationships with people in the construction industry. And so appreciate your sponsorship and your ability to get this presentation put forward along with Roz and Steve and trying to be able to have something we can use for the future to help get people better in the industry. So, and Chris is the man that makes all this happen, and he's our chief estimator, and he's the one that's put together the program. So, thanks.
Thank you, Dave. Next, I want to introduce our food sponsor for today, as well as the one that's making it possible for us to be able to participate via Zoom. Steve Gelb is the director of Emerald Cities of Washington and really has had a diverse career, and a career that provides breadth and depth to those areas that the firms that we represent want to pursue. From retail to energy efficiency and developing programs around sustainability. And so we're very pleased to have Steve here. So Steve, with no further ado, let's give him a warm welcome.
Thanks, everyone, and thanks for joining us on this webinar. This webinar is part of a series of our eContractor Academy, which we ran last fall to help small women, minority, and veteran-owned businesses grow and get into the clean energy economy, housing, and general construction. And the person who launched that for us in Seattle, this is a national program, but we launched in Seattle, is Roz Jenkins. And Roz's last day with Emerald Cities is today, but I would like her to come up here so I can recognize her and thank her as publicly as we get these days for all of her contributions. So in addition to the eContractor Academy, she piloted an HVAC training program that we've run 3 cohorts already and will continue on, and has just been invaluable in supporting our programs, and more importantly, all of the folks who have gone through the programs and cares about them and follows them. And I'm sure we're going to hear from Roz later on. So Roz, come over here. And we were pleased to present Roz with a gift certificate to Communion, and I want to promote this to everyone in the area. Communion is a Black-owned restaurant in the Liberty Bank building, which is a partnership with Africa Town, and it was voted one of the 10 best new restaurants in the world last year. So check out Communion if you can get a reservation, and you'll see Roz there. Did you want to say anything?
I would like to very briefly just thank Hoffman Construction. It's been a while that they've been supporting the Entrepreneurial Institute of Washington and Platinum Group, and also thank Dan. We could not have had a successful e-contractor program without Dan's support. He brought some of our key primes and a number of our wonderful subcontractors, and it's been an odyssey, and Emerald Cities and Steve gave me a chance when no one else would, and I would just like to thank him for that, and it's been, Emerald Cities has been good to me. Thank you.
Thanks, Roz. And so I just want to remind folks that we have one more session in this series. That's next week, Tuesday, June 15th at 5:30 Pacific time, and that will be focused on architectural work. But I'm going to turn it back over to Dan and the rest of the program. Thanks, everyone.
Thank you, Steve. We also, because of the technology that I mentioned earlier, we may be having a technology break, and that will be a good opportunity for those of you at home to deal with family and personal issues as briefly as possible, but to get back to the class so we can resume. Last but not least, we have our instructor, Chris Bjork, and he has just been a tremendous asset to Hoffman and our firms. He has provided access to information that makes it much more of a smoother process for our firms when they are being exposed to government contracting and the huge bureaucratic processes as it relates to us putting in what we would consider responsive proposals. And so Chris has been working with Hoffman for a number of years. I believe he started his career at Hoffman, and they have been blessed to be able to watch him grow within the company, and his work has included some of the largest, most complex projects in this region. No further ado, let's give a warm welcome to Chris.
Thanks, Dan. I'm Chris Bjork. I'm the chief estimator for our office here in Washington, and I've been doing this almost 26 years. I've been able to work on a lot of different types of projects. Heavy civil treatment plants like Brightwater, lab buildings like the molecular engineering building over at University of Washington. I've been able to work on office buildings, residential. If you name it, I've even worked on a couple of bridges too. So I'm going to bring that to here tonight to help work on, focus in on structural engineering. I mean, not structural engineering, structural.
You got a mic.
Structural estimating. We're going to focus in a little bit, dive down a little and focus in a little bit more about the concrete and steel, and really do some sample takeoffs on how to take the scopes of work off and price them out, and what you need to think about to when you do that. So our class objectives here are really to understand major structural systems, what those elements are, identify what you need to take off, be able to quantify the scope and price it out, and learn what goes into pricing. We're going to start off with the structural systems. We're going to talk about the primary, concrete and steel, and then we'll talk a little bit about some of the secondary structures, so other structural systems that they have, and then some of the systems that are more miscellaneous and deal with some of the minutia about structural estimating that are the little parts and pieces that go into looking at a broader scope like miscellaneous metals. Let's start off with concrete. So concrete, you can really boil down to your major elements of concrete construction into foundations. So the footings, mat foundations, pile caps, things that are in the ground that support the column loads. Slab on grade, that base slab, columns, walls, and there's a number of different types of walls depending on what their function is. Elevated slabs, and then slab on metal deck, which is a type of elevated slab that you use in steel construction with a metal deck that you fill with concrete. Focusing first in on the concrete foundations. So concrete foundations, we have different types of footing. So a spread footing, which is an isolated footing that takes one column load. You've got a wall footing, which will take a wall load. It's also called a continuous footing. A mat foundation or a mat footing is really a large spread footing that you'll typically see under like an elevator core or for an elevator pit. It takes a much larger area. It might have several shear walls on top of it. So it's taking a much larger load and is typically deeper, so it spreads out that load into the ground more effectively. The things we need to think about when we look at concrete foundations is we need to think about forming. So when you're dealing with concrete, you need to understand your formwork. That's what we build to make sure that the concrete stays in. You need to know your volumes of concrete. Then you need to look at some of the details here. So in concrete also, oftentimes you're going to have a shear key. So in a retaining wall, there's a little key that sticks down below the bottom of the footing that may need to be hand excavated out. Most of the times on a footing, your excavator will go out and dig the footings out. But some of these smaller things, you may actually have to have someone a worker out there with a shovel making that small foot by foot indention to make sure that gets excavated as well. On all footings and all foundations, you're going to need to hand trim as well. And that means you're going to need to dress up the subgrade, or if there's a rock base underneath it, to make sure that you're pouring the right amount of concrete in there and you don't have large divots, or you don't have a raised area that may impede where the reinforcing steel goes in the concrete. You also need the volume of concrete. So volume of concrete, length times width times depth. Make sure that if you have a depth of your footing is 10 inches, you want to make sure that you change that to feet. So you're dealing with feet. And then once you get a cubic foot, divide by 27, and you get cubic yards. Those are the important things. You need to think about where you put the forms to keep the concrete. Also on the wall footings in particular, you can have steps in the wall footings as the walls change elevation or the grade changes. You need to think about where those steps are so you can account for those in your forming systems and the extra concrete that goes around it. Concrete typically gets finished, and footings you'll take it and strike them off, but you don't include finishing in when you estimate footings because they're buried. You're not going to have a really finished surface. The one exception is on some mat foundations. Some mat foundations are actually mat slabs, and they will actually be a finished surface on top because of just the nature of how they've designed the structure. But that is the exception to the rule, not the rule itself. So that's just you need to look at your details on your plans and that will tell you whether it's the mat foundation is actually the finished surface, or if they put a topping slab or a slab on grade on top of it. Slabs on grade. So this is the lowest level. And you can have differing thicknesses. You can have a traditional non-structural slab on grade, which would be 4 to 6 inches thick. Or you can actually have a structural slab on grade. The difference between the two is a structural slab on grade is designed so that if the ground below it sloughs off, it can support itself as an elevated slab. Wherever you have bad soil conditions, so say around University Village, which is a former peat bog, you need to have pile supported structures, and because of that you may pour that slab on grade on the ground, but over time the weight of that structure is actually going to cause the ground below it to drop, and if you go in there a few years later there'll be a gap between the slab, bottom of the slab and where the ground is. The difference, really the big difference between that is you'll see the thickness and the rebar. But as far as the construction goes and how you estimate it, it's exactly the same because it's a slab cast against the ground. Starting with how you need to look at this, you need to look at your fine grading. So just like footings, you need to make sure that the subgrade is in the right shape to make sure that you have the right depth of concrete. You may have a thickened edge at the perimeter, so you need to make sure that you have that excavated and that graded well. And those are the hand excavation type activities that you may have. When you get into the formwork, the things that you need to think about are edge forms. So that's all around your perimeter. And that's just your perimeter times your depth. Now, we always assume that there's at least 1 foot. So if you have an 8-inch thick slab, for forming purposes, you have a 1 foot thick slab, because the formwork, when you start getting down below 1 foot, it's going to take you the same amount of time, whether it's 4 inches or whether it's 1 foot. But if it's once you get over 1 foot, you start using the actual depth. So if it's 18 inches, if you had a thickened edge form that was 2 foot, you want to make sure you use the 2 feet. You also have construction joints. That's where you're breaking your pours. And typically, will show you an actual drawing. They may tell you where it is, or they may tell you what the limits are in the specifications. You'd like to have those between 5,000 and 8,000 square feet of surface, because that's about what you can finish in one pour in a reasonable amount of time. Part that goes along with the construction joints are column blockouts. So column blockouts around a steel column or a concrete column, we'll put a diamond pattern around there, and that's really to make sure that that concrete stays intact and doesn't adhere to the column itself. And then as that column moves up and down, as it takes load, it doesn't cause the slab to crack. So you create a separate pour break there. You'll often put some expansion joint around it, and then you will take off those the concrete involved with it later, because it's a separate activity. Once the rest of the structure is done, you'll come back and fill those with concrete and finish them off. One other thing that does go, I recall, I see that I forgot one thing. Underneath the slab, oftentimes you will have a vapor barrier. And oftentimes that's the concrete subcontractor who's in charge of that vapor barrier to put it down. And when you look at the vapor barrier, you need to remember things like the actual area of it. You need to include something for laps and for your waste factor for vapor barrier to make sure that you quantify it correctly. But you have the other types of joints that you have are saw cutting control joints, and those are there to prevent cracking. You may have some formwork for slab depressions where you have stone tile and you need to lower it 2 inches to make sure that you have enough depth and the flooring flushes out nice and even once you get into your finish work. When you get into the finishing types of quantities, it's areas, so square foot of finish area, but that needs to include a number of different activities. So setting your screeds, which tells you, making sure that when you're pouring the concrete that you get the right depth of concrete. Finishing your area, the finish area, and you need to understand what types of finish you have. You could have a trowel finish. You may have a float finish. You may have a broom finish. You may have an exposed aggregate finish. Those are all different types of labor that goes into it, different types of material costs that you need to think about. And finally, you need to cure the slab. So that can involve either a water cure, where you spray water over it over a certain amount of time, or a chemical cure, where you actually spray a chemical compound on top of it, of the slab once it's been finished, so that the slab cures and you don't experience a lot of cracking, surface cracking on it. Next, concrete columns. So a concrete column can be round, it can be square, or it can be rectangular. Formwork, again, is you need to separate out round columns versus square or rectangular columns, because they're two different forming systems. A round column can be as simple as a piece of sonotube, but it can be, if you've got a lot of round columns, they have concrete metal forming systems that clasp together that can really make you much more efficient as you pour a lot of concrete and set up the forming for those columns. Sometimes columns have capitals on them, and what a column capital is this enlarged area at the top. You need to take the column, if you have column capitals on your project, you need to take those off separately, because that is not going to be included in your main column formwork. It's going to be a separate type of form that you're going to have to build. So there's going to be a different labor and a different productivity rate, different material cost associated with that. Again, you take off your volumes for your concrete, and make sure always divide by the 27. It's a common mistake that I see, is making sure you get that to that cubic yards. And then, like most, you need to cure and finish. Finishes for vertical formed surfaces can include a point and patch. That means you're going to go in there and you're going to patch any holes, or you're going to knock off any big fins that are left over on the concrete. You could have a sacked finish, meaning you're actually going to rub it down. It's a more architectural finish. You could have a skim coat finish, where you actually take slurry and skim coat the columns to make a really nice, smooth architectural finish. And sometimes you may have an as-cast finish, which is a form of architectural finish. So an as-cast finish, you're actually going to use a higher level of formwork, because it'll be an architectural grade form, which costs a little bit more. You're going to make sure that the joints are a little bit more caulked and tight, so that when you strip the forms off, it creates a nice surface that's there. And part of what the architects like when they do an as-cast form is that they actually want to see some of those imperfections of the concrete. They're highlighting the nature of that material architecturally. It can go very well with like an exposed wood structure to see that structural integrity of everything. Concrete walls. So getting into the vertical elements here. There are a number of types of concrete walls. You can have foundation walls, which foundation walls are below the ground. Typically they're going to be cast against, one side is going to be cast against earth. You can have structural or shear walls. So a shear wall is going to take the lateral load of the building, the earthquake loads, wind loads. Structural walls may take the gravity loads as well. You can also have stem walls. And what a stem wall or a pony wall or parapet wall, these are other names for them, are small walls. So usually less than 3 feet tall. You need to isolate these different types of walls, because they all take a little bit different labor. They take a little bit different finishing. There's other constraints. Shear walls will tend to have a lot of rebar in them, so you need to understand the rebar congestions of them. Foundation walls will have waterproofing typically on one side, so you need to understand what the finish for the waterproofing is going to be. And pony walls and stem walls, they're smaller, so you typically aren't going to get them all at the same time. They're less productive. They're going to take you longer, because you're going to have to piecemeal them as you go about when they're ready to go. Things to think about with the forming is the square foot of area. Do you have a two-sided form, or do you have a one-sided form? So some foundation walls will be cast up against a shoring wall, and oftentimes you will shotcrete those walls, which is a completely different activity. But sometimes you need to have a type of finish where you're actually going to put a one-sided wall form on there, which they have systems that you can use to support that wet concrete load, and actually then cast it with a one-sided form. treatment plants are a common place where you would see this, because going through a foundation wall of a treatment plant, you're going to have pipe spools, you're going to have sleeves, you are going to have embeds for pipe racks that need to have that firm surface to attach to, and they can be rather thick, and sometimes the thicker you get, the harder things get. Shotcrete tends to be to execute properly. Other types of formwork that you need to think about: wall bulkheads. And what wall bulkheads are the ends of your walls, and it's also where your pour breaks in your wall. So if you have a long stretch of wall, you're going to want to put a pour break anywhere from 40 to 60 feet, because that's how far an engineer is going to want you to place that concrete before you start getting shrinkage in between your pours. And especially if in a foundation wall, or if it's a water-bearing basin, you don't want the shrinkage, because that's going to means that either water is going to leak in or water is going to leak out, and we try to avoid that. Other things are openings. So openings for doors, you need to make sure that you take off the lineal footage of that opening times the depth of that wall to create a rough buck, to buck out that opening so that you have that formwork in place. One thing to note is that when you do your general formwork, so the sides, both sides of the wall, if you have small openings, you don't take out any formwork for those openings. So when you cast those forms, you're actually going to form the full wall as if the opening wasn't there, and then you will nail your bucks to that wall form, and then button it up with the other side of that form, and then cast your concrete around it. So you don't take out any wall formwork for the openings, unless you have a huge wall where you actually might be breaking it up into smaller pours. Then you need to plan your work accordingly and form where you need put the forms where you need the formwork. You may have brick ledgers. So on a foundation wall, which is just a notch out of the form, looks like an L, that the brick will come down and sit down and bear upon, and the wall will shrink down in size. It may go from an 18-inch wall to a 12-inch wall, and that's you need to quantify that with a lineal footage. Pilasters are also oftentimes in walls, and what pilasters are columns that are integral into the wall. You need to add the extra formwork to form out those pilasters to make sure that you account for that. And similar to columns, you have different types of finishes: point and patch, sack. You might have sandblasting finish, which when you sandblast, that's in addition to a point and patch finish. So you'll go in there, you'll point and patch finish it to get it all the major fins and big bug holes and things smooth. But then you go in and sandblast it to get that nice sandblast finish. Depending on it, there's different ranges of sandblast. So you need to look at what the specs say. You can get anywhere from a light sandblast to a heavy sandblast. Elevated slabs. So this would include any formed elevated slab. So a conventional flat slab, a post-tension concrete deck. It would also go to include some more specialty type slabs, like a waffle slab or a pan joist system. The main thing you need to think of here is you start off with your shoring. So your shoring and your soffit form is one activity. And that's the bottom. Again, think of it as you're making a nice dance floor to build this slab on. So you are going to run that formwork through openings. You're not going to worry about what openings when you take off that and quantify this. The other thing you need to think about is the height of the shoring. So anything over 14 feet high needs to be quantified as a high shore system, because that means you need to add it. And then you also need to, if you get into an extreme high shore systems, we've had decks on treatment plants that are shored 40 feet in the air. Well, that's not just a high shore system. That's a extreme high shore system. When you start looking at that, that's when you're going to want to talk to either have someone look at the shoring and see exactly what you need and maybe do some preliminary shoring design work, or talk to a forming system, whether it's an EFCO or a Perry, alumiform systems, and they can actually provide some of that formwork design on what that needs to be, because they have some pre-designed, they've got some of that design loads already worked out, and that can help you with what you actually need for the shoring there. Again, perimeter, your edge form, you need to make sure you form out your openings, put some formwork in there. Think about where you're going to have pour breaks, construction joints, and all these are, they're square footage, but they're really, it's a lineal footage times the minimum 1 foot depth, and it may be, you can have 2 foot slabs. A lab building that has a lot of vibration criteria is going to have a thicker slab. The molecular engineering building has a 2 foot thick, conventionally reinforced slab. It's one of the deepest slabs I've seen on a more conventional building. Finishing, just like slabs on grade, setting your screeds, the type of finish, trowel, float, broom. But the other thing you need to remember is that you may need to finish the soffit form too. And that's a dry finish, just like a wall. You need to look at your specs and make sure you understand what it is. Sometimes you'll have to finish it. Sometimes you won't have to finish it. If it's completely covered up, they may not have you finish it. There, they may, if it's a parking slab, they may just have you go down and grind off the big fins that are at your form joints. If it's an architectural finish, they may want you to grind it down and patch and make sure that it looks, it's nice and smooth there. And the last major concrete element is a concrete slab on metal deck. Here you have a corrugated slab, metal decking that you'll pour the concrete on. The things about concrete slabs on metal deck that you need to be aware of is, A, you need to make sure you use the right depth. The way that you'll get this denoted is 2 inches of concrete over a 3-inch deck. The common mistakes here are you put 2 inches of concrete in it and you forget about the 3-inch deck, and in those flutes you've got 3 inches of concrete. Or you say, oh, I've got 2 inches over 3 inches, so I have a 5-inch deck. Well, that's not right either, because they're flutes and there's gaps in them. So then you would have too much concrete. So you need to take the average depth. So if you have a 2-inch deck over 3 inches, or a 2-inch of concrete over a 3-inch deck, you're going to have an average of 3.5 inches thick. And you need to take the average of the 2 inches and the 5 inches, and that gets you the 3.5 inches. The other thing to think about is on a slab on metal deck, oftentimes you don't have to put in edge form, because the edge form is oftentimes metal form, an edge metal that is provided by the decking manufacturer and will be installed by the steel subcontractor. Or it may be, if it's a larger overhang at the edge of the beam, it may be a bent plate at the edge that you need to be aware of, because at that bent plate, instead of having your decking there, you're going to have a full depth of thickness. It's going to be more of a full 5 inches thick. So you need to account for that extra concrete, but you don't have to form that. But you do need to be careful around the openings, because sometimes some openings will be formed and other openings will not be, will have just the edge metal around it. You need to ask the questions, look at the drawings, look at the specs, and that includes looking at the metal decking spec to make sure that you can coordinate when you estimate the work. The last key piece of looking at slab on metal decks is looking at both the edge condition and the beam spacing. So the edge condition, if this overhang here past the beam is far enough, you may have to shore that edge or kick it back to the beam, because it's with the wet concrete load, which is a heavier load than when the concrete's set, may cause that to deflect, and you don't want your slab to dip at the end. You want it to maintain that nice flat integrity. That is usually the shoring on slab edges. I've seen it usually called out, but it's not always called out. So you may have to ask a question about that. I bring up the beam spacing because just like that situation with the wet concrete load, you may have to shore a metal slab system for during when you pour the concrete. The structural engineer will not tell you this. The structural engineer is responsible for the integrity of the slab in its finished state, so when the concrete is set. Structural engineers typically are not responsible for concrete activities, like what happens when you place the concrete. So you need to understand the beam spacing, and that may be asking a question to the structural engineer, hey, or it may be talking to the asking a question to the deck manufacturer, and the deck manufacturers will be able to tell you, hey, if you've got this kind of spacing and you've got this kind of load, you need to shore. If you've got if you're over a 10-foot spacing and you've got 4 inches of concrete over 3 inches of decking, yeah, you need to shore. You need to shore that while you're placing your concrete. You need to talk with the decking, and oftentimes the decking manufacturers like a Bjrk will actually have a manual. It's actually a steel deck design manual that will actually have charts in there that can tell you those things. So those are important things to acknowledge and know when you start looking at a deck, because sometimes you do have to shore that, and that's something you don't want to forget about.
Hey, Chris.
Yeah.
A couple of things related to that. Floor flatness criteria.
Mm-hmm.
And slab deflection go hand in hand there. Maybe you can address
Right. So.
So
Repeat that question.
Yeah.
So two things go hand in hand with that: floor flatness criteria and slab deflection and floor fill are three things that kind of go hand in hand with what you just said.
Yes. So what Dave's talking about is when you look at your specifications, they will have a floor flatness and a floor levelness criteria. It's typically called an FF and an FL number, and that tells you both how flat the overall floor is, and then the localized ups and downs. You need to be aware of what that criteria is to make sure whether you need to shore for that criteria, and to make sure when you screed that you maintain that criteria, because they will come back and measure whether you hit your FF and FL numbers. And if you didn't, you will need to floor fill. And floor fill is something as a general contractor, when I'm looking at and bidding some stuff, I will factor in some level of floor fill, because undoubtedly there's something that's going to go on. We're going to do everything right, and we still need to floor fill. But at that subcontractor level, you don't want to get into floor fill, because oftentimes when you start floor filling, it doesn't end. Because as soon as you start, if you get into a bad floor fill situation, the floor fill can actually cause more deflection, especially in a slab on metal deck where it's a thinner section. So you really want to concentrate on making sure you hit those FF and FL numbers. And if the spans are such where you're not sure if that's real or not, you need to raise questions on, hey, sometimes I can provide the thickness that you want, or I can provide the flatness and levelness. There may be you may need to work with people to understand what that is and what's allowable, what's going to be acceptable. Or you may just need to shore that slab and make sure that while you're pouring that concrete, you maintain the integrity of the floor flatness and floor levelness. But it is a big deal, especially when you get into office buildings. If you're doing a condo building, and while condos are typically not slab on metal deck, they're not steel construction, they are cast in place concrete construction. But nobody wants to have a condo that they've paid quite a bit of money for on that you feel seasick when you walk on it. Yes, questions?
Are we good, Travis? Hi, I just want to relay some questions that came in from the webinar, folks online. The first was, it was a couple of minutes ago when you were talking, and the question was, is it familiar with the hard rock in Louisiana, or is this a beam spacing issue? So Sergio asked that. I'm not sure, Sergio, if you want to be more specific, since I got your question a couple of minutes late.
So if you're talking about the whether or not you need to shore a slab on metal deck based on the beam spacing. It is not necessarily a beam spacing issue. It's the wet concrete load issue with the beam spacing. So it's something that you need to look at those, whether it's Bjrk or some other deck manufacturer, you need to look at what those criteria are. It's, again, the structural engineer is going to be responsible for the final condition. And the issue comes in is it's the decking and the concrete slab is fine for deflection at that beam spacing in the final condition, but it's not when you have the wet concrete loads. So you need to understand what that wet concrete load is and what in conjunction with the beam spacing to know whether you need to shore the metal deck or not.
And there was another question as well. And the question was, what is the lifespan of these different concrete structures?
Well, that depends. I mean, concrete, you can have concrete structures that are 100+ years, and if you think there are concrete structures here that are well over that. Concrete's an interesting material because concrete never always is gaining strength throughout its full lifetime. It's just the nature of that chemical process that creates concrete, which is the reaction of the water to the cement, and that hydration process is a process that actually keeps going throughout the life of concrete. And so concrete, in theory, is actually gaining strength always. It just changes the rate. It starts off gaining strength really, really fastly, and then it tapers off and kind of just keeps on going very slowly throughout its course. But the life of the building is typically going to be determined by the architect, and that's going to be more than just the structure of the building. It's going to be the finishes of the building. If you have a hardy plank or a wood siding building, that's not going to last as long as, say, brick or stone. So moving on to steel structures. So your primary steel structural elements, you're going to have columns, you're going to have beams, you're going to have girders, and girders are just large beams. So in a framing system, the beams frame into girders, the girders go into the columns go down to the footings. You need to think about your connections, and then you'll have a metal deck, which we just talked about with the slab on metal deck, but the steel subcontractor does the metal decking. So we'll talk about the decks here, and then there are some miscellaneous items that we'll talk about. Starting off with your columns, beams, and girders, we look at steel and we look at it two ways. So the quantities that you need to take off are going to be twofold. You're going to need to know the weight of the steel, the tonnage of the steel. You also will want to know the piece count of the steel, because the piece count will factor into your erection costs, because you'll have a crane to erect this. So erecting a 3,000 ton or a 3,000 pound beam is going to take a similar time to a 1,000 pound beam, because it's going to be the suspension of the beam is being done by the crane, and that the difference is just going to be how many bolts or how many welds you have, and that may take you more or less time. But you still have a similar amount of people working on that erection. So you need to know the count of the piece count for your steel, and then you need to know the weight of the steel in order to purchase the steel. Things you need to understand on steel: you need to read the specifications and know what type of steel you are. There are a number of different types of steel. They range in cost. You should also note whether the steel is galvanized, whether it's stainless steel. That doesn't come up in general building construction, but if you get into a different type of building, like a treatment plant, where you have steel that is exposed to corrosive environments, it may be you may see galvanized steel on the project, and you need to understand what that is and where it goes, and because that is an added cost. You need to understand what types of the connections are. Are they bolted connections? Are they moment connections? Are they welded connections? Do you have full penetration welds where you actually have to groove that and actually weld everything together? those are, a full penetration weld can be a very time-consuming and costly thing depending on how thick the steel is. And then we'll talk about the connections. And actually, for connections, you don't actually take off. Typically, you will not actually take off the actual weight of those connections, so the little clips that you have. Now, if you are actually doing the fabrication yourself, if you are a steel fabricator, yes, you're going to take off every clip and everything because you need to understand what that is to fabricate it. But if you are looking at it from as, I'm going to contract this work out and I need to understand what the costs are for my estimate, you will not take off all the little clips that are and little plates that are attached to the column for the connections. You will not take off the number of bolts. You will not necessarily take off all the welding. You will use a percentage. Typically, you will use a percentage factor for that. That percentage factor can range from anywhere from 5% up to 15%. And what the difference is depends on what your weight of your structure is. So if you have tube steel, so a hollow structural system, so it's a hollow tube that's 4 inches, 6 inches square, that's a lighter section. If you've got lighter sections, your connection percentage is going to be closer to the 15%. But if you have large, wide flange beams on a multi-story building, those are heavier sections. You're going to be closer to your 5% at that point. So you just need to understand what kind of structure you're dealing with. You need to understand how beams are labeled. So you have wide flange beams, you have channel sections, and those tell you what your weight per lineal foot is. So a W12 by 18 means it's a 12-inch tall beam that weighs 18 pounds per lineal foot. That's the same designation that you'll see for a channel section, except it'll be a C 6.5 by 10.5, for instance. The hollow sections, so what used to be called tube steel or structural pipe, now they're all called hollow structural sections or HSS sections. Those you need to look up in a book to find out what those weigh per lineal foot, because those depend a lot about the thickness of the steel that's associated with it. You can look up those. You can find the information online. If you have a steel manual, there's plenty of if you talk with the American Institute of Steel Construction, there are publications that you can have that list out all the weights of every type of steel. Both the structural sections and even plate steel, so that you can understand what steel weighs and what the different types of steel weigh. One thing to watch out for, though, and here's a thing that you need to watch out for with steel construction, and that is built-up sections. So sometimes you're going to run into a built-up section, which is, I need a structural steel member that they don't make. So there you're taking sheets of plate and cutting them down and actually welding them all together to create either a tube or an I-beam section. That's a custom section. That costs 2, 3, up to 5 times the amount for fabrication as a milled wide flange beam. Those are all full penetration welds. They take a long time, and it's quite costly. You don't see that very often, but if you've got a long span, if you're looking at even sometimes maybe a bridge, you may run into something like that, and you need to be aware of it. Decking. So with decking, you need to understand what types of decking you have. You have floor decking, you have roof decking, you have openings, and the openings are not always taken out in a decking plan. Oftentimes, you will deck the entire floor or the entire roof, and then come back in and cut in your openings for mechanical shafts, for pipe sleeves. And you need to understand which openings that as the steel contractor is going to cut in and open, and which one maybe the mechanical or electrical trade is actually going to do. Typically, the rule of thumb is if it's rectangular, between the steel sub and the concrete sub, they're going to handle getting that opening constructed. If it's a round opening for a sleeve, that's either the mechanical or electrical trades. That's the rule of thumb. but always verify to make sure and read your specs or your bid package instructions to make sure that that is the case, because that's not always, it does not always follow that way. You may just be putting some sleeves in, and they may tell you what sleeves to put in. And then also, just like everything we talked about with the slab on metal deck, know your edge conditions. The other thing that you need to understand about decking is on floor decking, oftentimes you have Nelson studs. Those will be called out on the drawings, and what those are a stud that's shot down with a piece of machinery onto the top of the beam through the decking, and that provides a composite structure so that the slab acts with the beam and adds more structural integrity and capacity to the full structural system. They will tell you how many, the plans will tell you how many structural studs you need on each beam, so you just need to be aware of what that is so you can add that in.
Before you go on,
Sure.
couple questions. Early on in the presentation, you had discussed, I guess, capacity on pours, 5 to 8,000, and you also mentioned, doing a run, lineal footage, for a break or an expansion or something
Right.
of 40 to 60. When a firm is competing or delivering a larger project, and a lot of your projects, you'll have maybe multiple crews going on concurrently. On a large slab, what would you do to maximize productivity? Obviously, if it was, say, over 100,000 square feet, what would be the technique to be able to, I guess, minimize the pours?
That's a great question. So when I'm looking at a concrete job, and we self-perform concrete, so when I look at a concrete job, I look at it as if I'm self-performing the work. I will look at the whole slab and look at, okay, well, how do I break this up into nice, even, where I can get nice straight lines, because you want to minimize your joints, and you don't want to have them jagged around. How can I maximize this slab into the minimal amount of pours? And I'll work with our concrete superintendents or our project superintendents to look at that. Sometimes those constraints are dictated in the specifications. A treatment plant will tell you you can only pour 40 feet in every direction. And that's because it's a water-bearing structure, and they don't want shrinkage on adjacent pores. They will also tell you that you have to wait so much time between the pours. So on a treatment plant slab, you actually do what we call checkerboarding the slab. So you will break it up into as much like 40-foot squares, 40-foot squares, and actually pour them like a checkerboard, the reds and blacks through there, and then come back after the certain amount of time and pour the slabs in between. That'll be dictated in the specs. In general commercial construction, oftentimes they don't tell you how much you can pour in one day, or in one pour. So you need to understand what your crew sizes are and how much you can finish in one day, because that's really what's going to be the constraint. If you don't have the crews that can finish 10,000 square feet in a day, you can only get 5,000 square feet on your day. Then you need to look at 5,000 square foot pours. Or you need to already have multiple crews finishing it. That's where you need to understand what your crew capacities are. But then you start off, and if you got a 100,000 foot square slab and you're doing 10,000 foot square pours, well, that's 10 pours. So now I have to know that it's 10 pours. So how do I break this slab up into 10 pours that are about the same size the most efficiently? And I'll actually, back when I started this, when we didn't have on-screen takeoffs, I would actually take colored pencils and actually draw where those things were. And part of being an older estimator is I think I have an honorary degree in coloring. But now with the blue beam technology, it's actually like blue beam and on-screen takeoffs, it's actually even easier, because now you can use all those colors to designate your takeoffs on the actual drawing. and it's to scale, so you can actually figure out how far this is, and actually use those lines that you're drawing and take the lengths of them so that you actually get your quantities out of it, and you get to do, not just break it apart and then have to measure it, but actually measure it as you're breaking it apart. It's much more efficient. But I've seen, it all depends on what your constraints are. If, I've worked on slabs where we didn't have to have a heavy level finish, on slab on metal deck, on a roof deck, where we were in a much warmer area of the country, and we poured 30,000 square foot pours. We started them at 3 in the morning, but we poured 30,000 square foot pours, and because that's what we could actually accomplish with the level of finish that was required.
Right. I'd imagine when you're doing that checkerboard technique, it becomes really complicated if your elevation is off throughout that process, or in any one play. You're matching things up.
Yeah. Well. Right. And that that just as a point on beyond kind of what we're talking about here, concrete construction in a treatment plant or a process facility is a different beast altogether than the production-based concrete that you see in commercial construction. In that heavy civil treatment plant construction, you need to understand that the concrete is almost acting as a piece of equipment. So you are going to make your money by doing it right the first time, because if you have to go back and do it a second time, you have a heavily reinforced concrete wall or concrete structure that you're going to have to demolish and rebuild. You have water stops everywhere, and it's not the bentonite type that's easy to put on. It is PVC water stop, and it will be non-negotiable on using something else. You will use the PVC water stop because that's the best thing around, and they do not want leakages in a water or wastewater tank. So you need to make sure that you understand on that and get those elevations right, because those slopes are there because sediments slope out of the water or wastewater in a settling thing, those solid materials that they're trying to get out of it, and they are moved out of the liquid stream and into a solid stream with that slope, and that slope in mind, and that's why those slopes are there. This is for the actual how the tank will work the way it's supposed to work.
Thank you. And then the last question I had is for a lot of the folks on the Zoom call and maybe even here today have interest in the finish side of some of these structural materials. And is there any rule of thumb as it relates to concrete surfaces below or above grade, or is there any rules of thumb as it relates to when should we apply the coatings to the steel? Before we put them on that crane, or after, or
Sure.
Is there any rules of thumb that some of our firms could kind of take note of?
Yeah, so let's talk concrete first. So concrete finishes, and I'll talk first dry. The bigger question is the dry finishes, because those are the finishes that are applied after you've stripped the forms, as opposed to a slab where you're applying the finish as you're placing the concrete. So typically you will see a point and patch is really the default finish that you would have on any wall or column. What you need to look at is you look at what's exposed concrete. So if it's exposed concrete, so architecturally it's exposed in the building, and in a public place or a place where the public is, not necessarily in a back of house or like a mechanical room or a pump room. If it's exposed in a public place, it's going to have a higher level of finish. You're going to need to understand what that finish is. That will be in the specifications. And you'll need to understand whether it is a skim coat, whether it is a sack finish, whether it is a rubbed finish, whether it is an as-cast finish, and then you're going to need to understand what your formwork needs to be, because instead of using a BMAT formwork that's the cheap formwork, you may have to use a HDO, a high density overlay formwork, which costs, especially now with what the wood's doing in the market, is going to cost a lot more money to get that. And you need to understand that if it's an architectural form, you're going to have to caulk between every joint of the plywood in your formwork to make sure that that is a nice smooth. The idea with an architectural form is that you don't necessarily see all the joints for your formwork. You don't see like if you look at the bottom of a parking garage on that formed deck, oftentimes you can tell where all the plywood was. If it's an architectural form, oftentimes they're not going to want to see it. But yeah, you need to respect. Sometimes they want to see that. I've run into architects who want to see all those imperfections in that design. They want that look. But again, read your specs, understand what the expectation is. With regard to steel and steel coatings, you need to understand whether the steel is fireproofed or whether it's primed. If it is fireproof, you don't want any primer on it. And if it is not fireproof, then you're going to want the primer on it. And you want the primer on it when it gets erected, except you'll leave it off where you have areas that say are welded connections, because the paint will interfere with the welding. The finish coat, so if you've got an intumescent type of fireproofing on it, which is a painted coating fireproofing, if you've got painted steel, if it's exposed architectural steel that gets a painting on it, a coating on it, you're going to want to apply that after the steel is erected. And the reason for that is that you don't want that coating on there when you're welding, or when you're bolting something together, or when you're swinging it in the air, because if it's going to nick on something and you're going to have to go in there and patch it. And some of those high-level coatings are not, they're a bigger deal to patch than just touching it up with a little paint. So the last piece, and I'll go a little quicker on this, the last piece of the steel structural elements are all the miscellaneous items. So this can be bracing, which you take off just like you take off, traditional bracing, you take it off just like columns or beams. Figure what the weight is and find your each count. Now, there are some specialty proprietary systems of bracing, like a BRB, or a buckling resisting bracing. Those are proprietary items that you'll need to talk to a specific vendor on. Those are usually you'll take off at the type of BRB and an each count with it, and you won't worry about the weight as much, because that's going to come from, the cost for that is going to be more of an each count from possibly a different vendor than your steel vendor, depending on how you're actually purchasing the materials. Open web joists and girders, you see those commonly for floors and roofs. They're a very efficient structural system. Those come from, again, a specific manufacturer, so like a Volcraft, and those won't always necessarily have the weights on them. You need to get to the weights to price them out, and the each count, same as any other structural steel. But to find those, you need to get the actual design manual from the manufacturers, and those are readily, if you call them up, they'll be happy to give you one. And those will have all the weights, and they'll tell you, actually even tell you, span lengths, and if you've got a span length of a certain loading, which member you need. Because sometimes those are design build, like here it says a 26K joist here. Well, if you look into the joist manual, there's 5, 10 different types of 26K joists that all weigh a different weight. So you need to understand which one that is. And so sometimes it's actually the joist manufacturer who designs that final piece of it, and not the structural engineer. But that's, again, if you're dealing with open web joists, you're going to need to be talking to a open web joist manufacturer to get that specific pricing as well. You may have a site fabricated truss, which is just, it's a truss that you bring all the pieces on and build the truss on site. That's going to take more time, because you've got to basically, you're fabricating the steel member on site as opposed to in a shop. So you just need to be aware of that. And finally, there can be some pre-assembled systems. So are you building some of this stuff off-site and bringing it in, or are you looking at a pre-manufactured metal building, which is a complete separate subcontractor that you would hire, whether it's a butler or another manufacturer prefabricated metal buildings. So that's the end of the primary systems. The other systems that you can run into are masonry systems, so concrete masonry units. We'll talk more about those on the architectural side because they're more, they tend to be an architectural element as well, but they can serve as the structure. You may have wood framing or light gauge metal framing structures. That's a conventional framing system, stick built. You may have a precast system. You see that on parking garages a lot, where you have actually precast concrete members that you purchase off-site. They're trucked in. You crane them and attach them in place just like you do steel. Very similar to steel construction, just a different material. And then you have heavy timber construction, and that can be glulam beams with glulam framing systems and decking. That can also mean cross-laminated timber or dowel laminated timber. You see that's our Founders Hall project over at University of Washington. This is actually a sample connection from that project. And that is, if you think of those materials, really that is precast construction, except the material is wood instead of concrete. And that's a really good way of thinking about it. Last piece is the secondary structural elements, and those are the small little pieces. For concrete, it's pads, curbs, stairs. They're not always going to be shown on the structural drawings, so you need to make sure you look at the architectural drawings and probably the mechanical and electrical drawings for the pads and curbs, because that will tell you sometimes where those pads and curbs go and are the approximate sizes of those. Miscellaneous metal fabrications, and that's everything that's steel on the project or made out of metal that is not a structural member. Brick ledger angles, railings, metal stairs. I will tell you this, that's a class in itself to figure out that. And I will tell you from experience, my experience says that you can never throw enough money as a general contractor at miscellaneous metal fabrications. No matter how much money you put in there, it will always come in more expensive because it's all these little supports that come in out of the woodwork. So you just need to go through and pour through those drawings to really understand where all these little supports for countertops, for toilet partitions, that may only be shown on the architectural drawings. You need to understand where those things are. And that brings us to a sample takeoff section. So are there any questions now before I move on to a sample question section? Great. So what we're going to do here is I've created a sample concrete and steel structure that we're going to look at: a footing, a wall, a slab on metal deck, and then for the concrete piece of it, and then look at the steel beams and decking on the steel side of it. So first thing that you would look at there is the concrete footing. So you need to understand in this footing it is 28 feet long, it is 10 feet deep, and it's 3.5 feet deep. That gives you an area of 280 square feet for your hand trim. Your formwork's going to be around the perimeter of it, and you take that 76 feet, which is, if you take the perimeter, it's 76 feet. You multiply it by the 3.5 feet, and you're going to have 266 square feet of formwork. Your volume of concrete is going to be about 36 cubic yards. For this exercise, we're going to understand that the concrete is 4,000 psi concrete. So there's different strengths of concrete, and you need to understand what those are when you look at a concrete structure. This footing is 4,000 psi concrete. We're going to assume that it's going to be pumped, and that the reinforcing for this concrete is going to be 150 pounds per cubic yards, which that times the volume is a little over about 5,500 yards, or 5,500 pounds. Once we've taken off the footing, we're going to look at the wall. So coming off that wall is 15 feet high. We are going to assume that right here at this level, at the floor level, we've got a horizontal construction joint. So where you have a horizontal construction joint, you need to note the length of that, because you'll typically put a keyway in there to make sure that the pour above it attaches in nice and tight, and you maintain that integrity of the structure going up. We're going to assume that the top of that wall is the 15 foot high, and we're going to finish that top of the wall. But this concrete is going to be 6,000 psi. Walls typically have an admixture added, and so it's a chemical added to them. They typically will have a super plasticizer added to them. And whether it's called out, it won't be called out on the drawings, but typically you will want to put that in because what a super plasticizer does is it makes the concrete more fluid. And that allows you to get a better consolidation around the rebar and in the forms. So as you pour your concrete down these forms here, that as you get down at the bottom, that you have a nice, you're getting the concrete all the way to the forms. And when you strip the forms, you don't suddenly have rock pockets or holes in the concrete. So you take off your quantities. We'll need some wall bulkheads here, the horizontal keyway. One thing that we need to note is that we've got steel beams coming into this wall, and we've got deck coming into this wall. Those beams are going to have embed and a plate embedded into the concrete that we're going to need to install. So we need to take off the 3 embeds for the beams, but that decking is also going to need an embed because this decking is going to need to have to sit on something so that connection doesn't flop and doesn't deflect. So you'll have an embed, a continuous embed down the 24 lineal feet of it that the steel sub will come back and put in an angle there as part of their miscellaneous metals package. We're going to assume, for the quantities, we're going to assume that this has 180 pounds per cubic yard, and it's going to have a point and patch finish. Also, this will be pumped as well. And then moving on to the last piece of the concrete takeoff is the slab on metal deck. We'll take off that area. So the area is 288 square feet. We have a 3 inches of concrete over 2 inches of metal deck. So that average depth is going to be 4 inches, which means that the volume of the concrete is going to be 3.6 cubic yards. We're going to assume that this around the edges, that's edge metal. It's provided by the decking manufacturer, but we've got a construction joint right here. It's 12 lineal feet of construction joint. We need to account for that. We're going to have a trowel finish on it. This concrete, though, is going to be 3,000 psi concrete. It will also be pumped. So these are things that we need to start thinking about when we start getting to the pricing mode of this. So if we take our quantities and put them into a estimate summary, the things we need to think about here. Start off hand excavation. Things like hand trim on your footings. We put those quantities in there. Then your form work. You've got your form footings, you've got your forming your construction joints on your slab on metal deck. You've got the formwork on your shear walls, and you've got setting your embeds. These are things that carpenters do out in the field. So you'll put in those quantities. We've looked at, hey, we've tracked our production rates, what our crews can actually put in per unit of measure. That's what a productivity unit is. That's hours per unit. To create total man hours, we know what our wage rate is, our fully burdened wage rate. So not just the basic wage that you have, but all the adders that go on top of it for taxes, fringes, workman's comp insurance. We'll include that. To get a total labor, we'll look at our material pricing for the different formwork, figure out what our material pricing is. We'll total those off on the side. Then we'll start looking at the placement of the concrete. So each type of concrete is going to take a little bit different productivity to place. Walls are typically a little bit less productive, so you have a higher productivity unit to place than, say, a footing or a slab. But we're denoting what type of concrete here it is on the side, whether it's 3,000, 4,000, or 6,000. And that'll be important for when we go to buy our concrete. So we'll need to figure out how much concrete we need to buy. Now, when you start buying concrete, you need to understand that if you build a 3 foot by 3 foot by 3 foot box, which is exactly 1 yard of concrete, and order exactly 1 yard of concrete, you will not fill the box. You will lose some concrete in the truck. You will lose some concrete in the chute. You will lose some concrete in the pump. You'll have some concrete that gets shot off the side and not out of the form. So you need to understand what kind of overage you need to factor in for your purchase of concrete, because that is our responsibility as a contractor, whether it's a subcontractor or a general contractor. If we're self-performing, that's our responsibility to figure out what that factor is. standard rule of thumb, if you're dealing with a lot of formed concrete, is 3 to 5%. If you're looking at not, footings that are built on, the types of soil like maybe a riprap that's got a lot of voids in it, I've seen concrete get up to 20%, 30% overage. Those are where you actually have a neat cut form. So you're not actually forming it. You're just digging the earth out and casting the concrete against the earth on a riprap form where you have a lot of voids. And for starters, you're going to have more. Your excavation is going to be a little bit larger than what your actual footing is, and that's just going to cause the overage to get higher. You're going to put more concrete in the ground. So we need to understand what each type of mix that we have. Those all have different costs. A ready mix supplier is going to charge you an environmental fee because they need to. They have to deal with their cleanup. They will charge you a fuel surcharge. Now, a fuel surcharge is typically always going to be based on the number of trucks you have, not the cubic yardage. So you need to find a way to convert that to the number of loads that you have and number of trucks you have. Typical concrete truck is going to hold 10 yards. Now, unless you have exactly quantities that end up exactly in units of 10, you're going to have partial loads, so you need to factor something less than that. I typically factor 8 yards per load because some of our loads are going to be smaller than 10 yards. And that way I get a nice round, I factored in some of that forward thinking of the realities of construction. You'll oftentimes get a winter surcharge if you're pouring in winter months. And that's to help maintain the concrete at a certain temperature. So I figured that 25% of this cubic yard of this work is going to be in the winter months. So we're going to need to add an additional surcharge of $3.50 per yard to make sure that we're paying the right amount of money. We also need to add in what our super plasticizer costs are, because that's an added cost to your mix. And because we know that we're putting the super plasticizer in the walls, we're going to make sure that we factor that in. Then we move on to the pumping. Now the pumping is going to be more of a subcontracted cost because that's often you're not doing the work yourself. You're paying another company to come in and do that work. With pumping too, you keep that same overage in that we use for buying the ready mix as well, because what's going through the pumping is going to be more than just the same yardage. It's going to be about what that same type of overage that you see. So you need to make sure you factor that in. And then you come into the finishing of the concrete. So we're just finishing the slab on metal deck, and we're just finishing the walls. So the footings don't get a finish on that. But we need to factor our settings, our screeds, putting a trowel finish in, and curing the slabs. And then on the walls, we're finishing the top of the walls, and then putting a point and patch finish on, and then curing the walls. And those have labor associated with them. So you have productivity units that turn into hours, that turn into get a wage rate applied to them, and then turn into dollars. But you also have some materials because you have to pay for some of your curing compound, or you'll need to pay for your the grout that you'll use to help patch the holes. The last piece is concrete, is the reinforcing. So you need to take your reinforcing steel. One thing that you'll need to factor on is lap and waste for your reinforcing steel. Now, what I figure is usually 15% for lap and waste. If you are actually a rebar fabricator doing the work, you will probably have being laying out exactly what those lengths are, because you'll be fabricating to those lengths. So you'll know exactly what your waste is, because you'll know that, hey, I've got a ton of 14-foot bars and I'm going to buy them in 20-foot sections. So I've got 6 feet of waste on each one of those that I'll have to either figure out where I'm going to use, or I'm going to have to figure it as scrap. And you'll actually work on know what all your laps are. And those are will be in the structural drawings, what those dimensions of lap need to be. if you are a rebar fabricator, you're going to get to that level of detail, and you will not necessarily put a lap or waste factor on it. You may have a contingency factor on it because you know that your general contractor is going to have you order 10 20-foot sections of rebar because they know that their carpenters are going to steal a couple and use them for something else. Those are things that happen. We discourage that from happening, but oftentimes you have rebar that's even, comes up and like, hey, I need some trim bar here, and you want to have some extra rebar on site for those last-minute trim bars, so you don't have to call up your fabricator and come back on. That's the big reason where you actually use those extra bars. Once you've got those totals, you can total them up, and then we need to add on our markup structure. So our general conditions and requirements and equipment, making sure that we've, how we're going to staff the job with our non-productive project managers, superintendents, what we're doing for safety, our safety program, things like that. We're also going to need to look at, do we need to bond our third-tier subcontractors? Do we need our own bond? What kind of taxes do we need to put on? And that all adds up to a total price. So for this, we've priced this out at just over $49,000. And that's how you would price out in a detailed look on what your concrete structure would be.
Now, really quickly, looking at the elevation image that we were looking at originally when we started this process, someone would look at this and they would calculate, what the square footage, what the cubic yards is, and they would come up with a quick number. But as you can see, Chris has done a very thorough, itemized, 25 activity that really itemizes every piece. And so you know exactly how that material is going to be finished. You're giving consideration to the forming material and what kind of damage the forming material is going to have when you're pulling it off. And one thing I wanted to get into really quickly is, obviously, if concrete dried really quick and cured really quick, you could kick ass in production. But like you say, it has to cure. Mm-hmm. And so, what are there some rule of thumbs? Because obviously, we're talking about a footing, and then we're talking about a wall, and then an elevated wall on a steel structure. And so we got a few different pieces that are going in there. Can you give us a little insight on that?
So, depending on what element, the type of element, whether it's a footing, whether it's a slab, whether it's an elevated deck, you're going to have different requirements on how long you can wait to apply loads to those structures. Most things, like a lot of times things like footings, you need to the concrete needs to get up to a certain strength. So that's not the full strength. So if it's a 4,000 pound PSI concrete, that means at 28 days, the concrete on average has reached 4,000 pounds per square inch of strength. Typically, it's a factor of that, and that factor is going to depend on what the engineer really wants. Some engineers want to have a higher factor or a lower factor, but oftentimes it will gain that strength within 3 days, 7 days, and for slabs, walls are a little bit different because you have to keep the forms on longer, because you have to make sure that you get enough integrity that when you strip the forms and the braces off, or you may strip the forms off and put the braces back on, that the wall is going to maintain structural integrity. So again, if it's a 6,000 psi wall, you may wait till it gets up to 4,000 psi, and then you're allowed to strip. It may be a day. It may say the specs may say you have to wait 7 days to strip. That's why it's really important in the structural construction to read those specifications. Those specifications will tell you what you need as far as how long you can wait between adjacent pours. It'll tell you how long you need to keep your shoring in, and how do you need to shore 1 level down, 2 levels down, 3 levels down, as far as what your reshores are. And what reshores are is just you've stripped out the formwork and put the shoring back in. You need to understand what those are. The slabs can range, you can change your mix design and get those approved to get, say a 3-day, 3,000 pound mix that will allow you in 3 days to get back on that slab and start erecting column forms if you're going higher, or you can put on, you can actually use an accelerator in your slab concrete, which is another admixture. And what that does is it accelerates the curing, the setting of the concrete. So it gets the concrete harder quicker, which will allow you to be more productive oftentimes when you're forming. But it'll allow the concrete to be harder faster so you can get on it quicker to start setting forms or getting on it to, if you have not soft cut, so wet cut saw joints, if you've got hard cut saw joints in a slab, it'll allow you to get back on to make some of those cuts quicker. It'll allow you to apply load back onto it as well. And that's dependent on the actual mix design and what kind of admixtures you add into it.
And those, again, are additional costs.
Those are additional costs.
You may be able to save money in production,
right.
But you lose money in material.
So that's something you have to think about as a contractor when you're pricing it out, which is, we'll get into a little bit later. That you need to think about, hey, can I use if I'm going to be more productive using a 3-day, 3,000 pound mix, and I'm going to make, say, increased productivity, I'm going to make $10,000, but it's only going to cost me an additional $2,000 for the concrete mix, the premium in the concrete mix, then I want to get that mix approved. And when you look at mixes, sometimes they'll have provisions in the specs for those types of mixes. And so when you submit your mix, you can ask for a substitution request to get that in there, and it tells you all the requirements on it, so you can plan ahead for it. But you just have to make sure that you do the formal substitution request to make sure that you have that well documented. But yeah, you look at those productivity issues and where I can do gains. Does it make sense to do accelerator in the concrete? You can run into some crazy things too. The first time I was on a job that poured, I think, 10,000 psi concrete. We found out that you had to, and this is 20 years ago, you actually had to add superplasticizer and accelerator to the concrete because to get to 10,000 psi concrete, you have to have a lower water to cement ratio. Right. So you have to add more superplasticizer in it just to make it workable. And if you add a lot of superplasticizer, you actually retard the concrete, which means it sets up slower. So what was happening is that you had so much water superplasticizer in it that you were retarding the concrete. So you needed to add accelerator to it to make sure that you counteracted that, so you could actually set up, do your full pour and get it to set up. It was something you learned right in the field on it, but we learned it really quickly, and so we could make that adjustment. And, it's one of those lessons learned to ask questions at least.
Thank you.
Okay, so let's move on to get the steel structure taken off. So we have 3 W12 by 26 beams that are 11.25 feet long. We'll take those off. We've got a W14 by 30 beam that's 24 feet long, and we've got one of them. That's what we have for steel. That gives us a total steel weight of just shy of 16,000 pounds, and four beams total. Looking at the steel decking, we've got 288 square feet. We've taken this off with blue beam, so we've just taken off the area itself. If you don't have blue beam, you can length times width to get that area. There are no Nelson studs called out, so we don't have to worry about the Nelson studs. And so we move on to a pricing exercise there. So we've got, look at the purchase there. We're looking at the weight of the steel, the 1,598 pounds. We know we don't have to figure sales tax on steel because the steel is a part of the permanent structure. So it's not a consumable thing, so we don't have to figure the sales tax. It is taxed. It's going to be taxed on the overall job as in typical construction. We'll add 15% for the connections here because those are still pretty light members. That adds another 240 pounds. Then we'll figure $1,000 each for each beam that we're going to erect. But that's what it costs to erect them. It doesn't include the cost of the crane. So in this project, well, the crane isn't provided by the general contractor. It's a small project. General contractor is going to have the steel subcontractor provide it. So that means we need to think about what that cost is. So we think we can erect this over 3 days. We've talked with a crane supplier who can supply an operated crane, and they tell us that it's going to be $4,500 a day, all in, to move it in, move it out, and erect the crane. What those costs are, you need to talk to the crane, because that's going to really depend on what capacity of cranes are when you actually price that out. We factored in some general conditions and equipment and some markup structure, put some fee on it, and have a total there. Then we've looked at the decking, so we figured we're purchasing the decking at $3.50 a square foot. Then we're going to install the decking at $2 a square foot. Price that out, and you get a total of about a little over $35,000. And we're looking at this as if we're subcontracting the work out, not necessarily self-performing it. But we may be having 2 subcontractors do that. We may be buying the steel from one subcontractor and paying another subcontractor to erect it. We may be buying the decking from a third party that's not the steel fabricator. So there may be 3 people involved, 3 different subcontractors involved underneath us to do this work.
And real quick, the sequencing of these 2 takeoffs would be, obviously you're installing your formwork, your steel, you pour your concrete, footing, you pour your wall, and now you're in a position to be able to install the steel. And so those 3 days are after the wall's poured.
Right. So the sequence of what that is, if you're looking at the construction scheduling and sequencing of how that goes, you pour your footing, you pour your wall, you install your steel, and then install your decking, and then you'll pour your concrete slab on deck. And that's how it would factor into how it looks in the field when you build it. But that's something you need to think about when you're looking at pricing your concrete work, for instance, because that slab on metal deck there's going to be a gap between that wall and when the slab on metal deck gets placed. So you need to make sure that your crews can move to another area, either move to another area of the project to stay busy, or you need to factor out that your crew's going to have to go off-site and then come back. So that's a pricing consideration that you need to think about. Yes?
Chris, just in listening to you describe this, it seems to me I'd want to be talking to some superintendents who do this work and understanding the sequencing and the tricks and all the little extras. Is that part of the process as you're doing this work?
Yes. I do talk to my superintendents to understand and look at their schedules too, because the schedule is really going to dictate what that sequence of work, and the superintendent's really going to be the person in charge of that schedule. So you really are going to need to be in contact with your superintendent, with your project managers too, because they're going to dictate a little bit about what their vision of buying out the project is, and to really understand what the sequence of operations is, because sometimes there may be things that are unusual to a project, and we'll get into that.
You need to know how much forward you need.
Well, yeah,
forward, right? That's
right.
part of the schedule.
Right, exactly. You need to know, if you are only going to be able to, if you've got, say, 1,200 lineal feet of wall overall, and that's over 5 levels, so you've got, say you got 20 pours. Are you going to be able to sequence that where you can use one set of forms for everything? Do you need 3 sets of forms for everything? And how many, if you've got, depending on how many sets of forms you are, how often are you going to have to actually take the plywood off the form and put fresh plywood back on? Because you can only reuse plywood so much before you're just not going to get the right finish on it anymore.
Thank you.
So moving on to the last piece of this, which is the pricing considerations. Talking about labor production. We're going to talk about labor rates, material pricing, equipment pricing, and then you get into logistics, which is really the art of estimating. Those are the experience and things that aren't necessarily shown on the drawings that you need to understand and plan for. And then we'll go over the general, what the markup structure of that needs to be. So looking at labor production, where do you get those productivity units? That's kind of the big question about where do you get those? You can get those in trade publications. So an RS Means Guide has labor productivity units. If you're coming across something you haven't seen before, the labor productivity units in an RS Means Guide is a perfectly good place to start. I will use those sometimes if I run into something that I haven't seen before, so I need to factor in, hey, what's it really, I haven't seen this before, what's it take to install this? Or maybe it's something that I haven't seen before that's not actually in the RS Means Guide, but it's real similar to something that is in the Means Guide. So I can base it off of a new type of panel, say, or it may be a certain type of formwork that looks like a wall or a corbel or some kind of unique structure, but I don't have any historical data on it. So I'll look in maybe a Means Guide to see, okay, well, is there anything that's similar to this, and figure out what that productivity rate needs to be. The best way that you can do productivity rates is track your own productivity. And if you are not tracking your own productivity out in the field, you should be, because that tells you what your actual crews can do, and you need to track them per what a reasonable unit, because as estimators, you see all those line items, the details, and that's typically a reasonable unit. But some of my estimates get, that's a summary level of what some of my estimates look like. Can be fine pieces of reveal strips and chamfer strips and all sorts of other things that go into a concrete that I need to account for in costs. But they're impractical to track in the field because you can't, a worker out in the field is not going to be able to separate his time out. So you need to make sure you track those productivity units in reasonable quantities. Square foot of wall forms, the type of wall form it is. So it's easy to separate out a stem wall from a shear wall. Those are 2 different walls you're going to be pouring on, and it's easy for a worker to track his or her time to those walls. And then the quantities, and then you've got hours and you've got a quantity, you've got a labor unit. But tracking that in-house production of unit is key. That tells you not only the importance there's that really, it says your past performance, that's knowledge. And you can tell whether you're tracking to the right numbers. When you do an estimate, you can look at what you've done in the past. Hey, my wall form number is a 0.350 productivity unit. Historically, what I typically do a wall unit for is a 0.2. Why is that different? So you can look at that, because sometimes there may be a lot of levels of detail and some very specific things that change the estimate you're looking on from what you've done historically in the past. But understanding that there's a difference there allows you to think through what those differences are and make sure that you are not just, sometimes you can build too much detail into your estimate for cost, and if you don't take that 30,000 foot level and back pass it to make sure that this makes sense, you may end up pricing yourself out of the bid because you're doing a great job taking a detailed look. And that has happened to me, and it will happen to every detailed estimator at some point in time. So that's why it's important to have those units to be able to back check them. Last thing about productivity road is crew basing things. So some subcontractors are you might look at this instead of a productivity unit. You might look at, I have a crew unit. So I've got a crew that's made up of three carpenters and one laborer, and they're going to go out and they can put in X square feet of forms a day. And that's how I'm going to create that productivity unit and the wage rate. That's a perfectly acceptable way to do it. What I use that for is I use that for back checks, and it's a kind of response to talking to your superintendent. One project that we're working on, we had a third-party estimator on it, and they were quite, their job is to scrutinize and question numbers because they've got a different opinion, and we're trying to work together to get them up to what the right number is. Well, they questioned our concrete numbers. So I sat down with the superintendent and said, let's crew build this thing. And we actually went through and figured out what crews for the whole project and created the man hour, the hours, and then created the whether that was carpenters, laborers, or finishers, and be able to price that all out and come up with the hours for the project and the cost for the project on the labor side to see how that matched up with how I did it, looking at it completely different. And they came out really close. That was good. But that also allows you to, if they don't come out really close, well, you might have a disconnect with how the superintendent sees this job running. And that's an important thing to know, because that doesn't mean that necessarily the superintendent's right, or you may have a different idea that may be more efficient, and the superintendent just needs to understand that. It may mean that the superintendent knows something from his or her experience that you don't see. So it's important to have that conversation if there, because then you can find some real efficiencies in building, how you build that job in your head on paper and how you price it out. Labor rates, well, you need to understand are you union, are you open shop? What's your base wage versus your fringe? Unions, you can get all that information. You should be tracking what those units, those values are and what those rates are. Material pricing, you're talking to your subcontractors and vendors, making sure that they understand what you're after and and you understand what they're going to provide. That's a communication thing. So if you're getting a formwork quote from, say, a Perry Forms, you want to know that you're going to want to know how many sets of forms you need and how big those forms need to be. And you need to be able to tell them that so that they can tell you how much that's going to cost for each set of form. And you're going to need to understand what are they including and what they aren't including, because you may need to add some added costs for, say, a reveal strip or a keyway, or there may be something in there that they don't have. And you need to understand what that is. You need to understand that before they get you the quote, because you may be getting the quote on a bid day, and you don't want to have to suddenly have to try to take off more quantity on bid day on the fly, when you should be concentrating on what that cost and getting all that cost all put together is. And lastly, equipment pricing. So are you renting from a third party? Do you own your own equipment, or are you renting it back to yourself? Does it make sense because the project is long enough that instead of renting your equipment from a third party, does it make sense to buy the equipment? And it may mean that you pay a little bit more on that project, but now you have you have maintenance costs with that equipment. But now you have your own equipment that you can rent back to yourself or not rent back to yourself if it's a really tight market. You have that option because you own the equipment. Does it make sense for you to have an opportunity to actually purchase equipment and create some of that for your company?
And in that case, you would want to make sure that you're not necessarily putting all the cost of that equipment on that one project.
Right.
You write a fraction or whatever that percentage is.
Yeah.
If you're renting equipment, maybe you'd use the value of what the rental cost would be. But you definitely don't want to put it all on one job.
Right.
You may not get it.
Absolutely. So you look at it as a business investment, and it's over several jobs, that I'm going to be able to reuse this on several jobs. And so I can get just what it should cost there, and then I can prorate that over the cost of several jobs. And that's a great thing. Logistics. So this is the art of estimating. So this is where you're talking about those schedule considerations. When is the work happening? Is it happening now? Is it happening 2 years from now? You need to understand that because your wage rates are going to change, your material pricing is going to change. You need to factor that into your estimate. Is there adequate time in the schedule? Sometimes, as a general contractor, we have additional constraints on how the sequence of work is, where we know there are areas where we're going to have to double shift. You need to know where those areas are, because if you see that, hey, there's a week and a half worth of work here in a week's worth of time, I need to factor in some overtime to do that. Or I need to factor in a second shift to get the work done in that amount of time. And that may be, on a second shift on a union rates, it means you're paying $8 hours worth of work for 7.5 hours worth of work. You need to understand that there's a half an hour that's going to be lost in your productivity, and factor that into your wage rate as far as what that scheduled overtime premium is. And then what work will be in your way? Sometimes there are constraints about when you have access to put things in. An example of this is the light rail station at the University of Washington. We built that top down to build in all the struts that support that, and then once we got down to the bottom, we built it back up with all and filled in all the decks. That allowed us to great access going down for those big pieces, and then it was conventional going back up. However, what you don't have access for when you go all back up is how do you get the escalators down in there that go all the way down? So we had to understand that the escalator was going to be down there, and we needed to form and plan our shoring around that escalator, both to protect it and to make sure that we had the additional shoring towers that we needed and additional sizes of beams, shoring beams, to frame that shoring system out to span over that escalator. That was a constraint that you needed to know about. Then site conditions. What are your access points? Is it tight? Are you forming walls where you may have a wall and they want the positive side waterproofing, so it's not poured up against the shoring wall? So you only have 3 feet between your wall and your shoring wall that you got to be able to get a formwork in and a worker in to get that done. And it may be a 20-foot high wall, and now you've got some pretty hard constraints. Is that adequate? I mean, you need to look at, is that adequate? Am I going to lose productivity because of a tight constraint just space-wise and just getting the work in place? You need to understand what your hoisting is. Is the general contractor providing hoisting? Are you providing the hoisting? Is the general contractor providing a certain amount of hoisting, and what is that capacity of that hoisting? And do you have to make a pick that's going to exceed the capacity of that hoisting, which is going to require you to bring in another crane in? Just because the general contractor has hoisting on doesn't mean that it's going to be adequate for all your needs. That will come into a play sometimes in steel erection, or if you have a tilt panel wall, which is a site cast precast. The crane that the general contractor has on site may be sized perfectly for all the steel structure, but that tilt panel wall is going to exceed the capacity of the crane. So you need to bring in a mobile crane for that tilt panel erection job. Those are things you need to think about. A good general contractor will tell you what the capacity of that crane is, so that you'll be able to figure what that is. They'll tell you what the radius is and what the picking capacities at the different picking points are. If you don't see that, you need to ask that question of your generals to make sure that they are providing that, because you need to know that. And where's your laydown and storage? Do you need to? Are you going to need to store some materials off-site because it's just in time and there's no laydown? Are you going to have an area where you can lay down, formwork? Are you going to be able to lay down steel beams and store them there? You need to understand what those constraints are. And the last piece is markup structure, and I'm not going to dive too deep into this because markup structures is really it's a separate class, because there's a lot to that and a lot to what go into general conditions and general requirements and where you get what kinds of insurance and stuff. That's a class we've talked about doing. So, but it's a it's something that you need to dive into. But general conditions, general requirements, that's how you're staffing the project. Those are the, are you providing hoisting? That is it, what's your safety things? Do you have a couple laborers on site that are not there to do any of the actual direct work, but are just there to help maintain your site and maintain that your area is clean, and sweep up and clean up, so that your workers that are doing the actual work in the field aren't having to spend time doing that, and they can be more productive. You need to think about it. What kinds of insurance do you need? What kind of insurance are required? What insurance maybe that the general contractor may be providing for you? For instance, like a subcontractor default insurance, where that would prevent you from possibly having to get a performance and payment bond as a subcontractor. You need to understand what those things are and what is required for the project. You need to understand, do you need a bond? Do you want to bond your subcontractors? As far as third tiers, you want to know what those costs are, and talk to your bonding companies to find out what those costs are. Do you need a bid bond? Are you going to provide a bid bond, or are you going to write a cashier's check? It depends on what, every company is different, and I've seen both come in from subcontractors when we've bid out work. What taxes do you have to put on? Is it, we've got a B&O tax in the state of Washington. We've got a sales tax. Now, you always have to put sales tax on your consumables. If it's not a permanent thing, you always need to put that on. But is it a tax rule 171 job, which is section 171 of the tax code? It typically applies to federal jobs with federal money that are highway jobs. But that means that you don't put tax on, the general contractor doesn't put tax on the total. And you don't get that exemption from the general contractor that says, yeah, I don't have to pay tax on my permanent materials. It means I have to pay tax on my permanent materials, because the federal government is only going to pay tax on materials, and it's not going to pay tax on labor. So you need to understand that also applies to your equipment rental too. So you need to understand what those constraints of that project are. And that will be spelled out in contract documents. And then fee. What are you willing to do the project for? And what goes into the fee? Some projects they may tell you to put some of your insurance or taxes in your fee. We see that a lot in our GCCM work that we do, where our fees are to include things that are not just fee. But you need to understand what your overhead is, what your profit you expect, and what risk you're taking to do the works, because that's going to affect how much you're going to be willing to do the work for. Those are the things that you need to think about when you mark up the structures. And that brings us to the question, if there are any additional questions.
Okay, we're going to give folks on the Zoom call an opportunity to give some thought to this great presentation with all this wonderful content, and be thinking about some questions that you may want to pose to our instructor. In the meantime, we'll go through our conclusion, and when we have some questions posed up, we'll go ahead and tap you for those.
Great. So what we've covered today, we've covered structural scopes for estimating. We've talked about how you take the structure off, and we've talked about things to think about when you do the pricing. All of this applies to new items, because as an estimator, you're always going to find something new that you haven't seen, or something that's a one-off. I've estimated for 20 some odd years, and suddenly I get a job on my plate and in my workload that's renovate the Space Needle. Don't come across those kind of costs and how you do that every day. It's not a job that even the historical data on that really isn't going to really apply to anything beyond that job. But using the techniques I had to how you quantify, how you look at what units you're going to have and what your vendors are going to give you, so that you understand what units I need to have my quantities in, so to get the right pricing in, and how to contact and get that pricing, and have the right people looking at different scopes of work, and what goes into the details of what the job is. All of that applies, and you use those same principles to something new, so that you can make sure that you take that off and estimate something new efficiently and accurately. It's the same principles whether it's something you know about or something you haven't known about. You just need to ask the right questions and apply those principles to the new situation. Lastly, we're talking about future opportunities at Hoffman. Now, these are jobs that we have coming up. In pre-construction, we have the Overlook Walk project, which is a part of the waterfront redevelopment. Basically it's a pedestrian bridge that's going to connect Pike Place Market down to the aquarium. Really cool project. It'll really make a really cool splash on the waterfront. It'll start bidding out this fall. We're doing a pool renovation over at the UW for the IMA building. That's a design build project, so we'll be starting procurement this summer, and that will go into the fall. And Project S is a private developer office building project that will start bidding out late this year and into early next year. Projects that we are proposing on, but these are design build projects, so we will be having to put a price together as part of the procurement process. It's the King County Metro interim bus electrification design build project. So King County's moving to electrified buses. They need an interim place where they can charge these buses at. We'll be procuring that this summer and into the fall. And we're doing West Point treatment, electrical upgrades to work out at the West Point treatment plant for some improvements there. We're proposing on that project. We should start procuring that work for our proposal in the fall as well. Finally, the next class is going to be 1 week from today. We'll be talking architectural estimating. A lot of material there, but same format. We'll talk about the key elements. We'll do a few sample takeoffs. Then we'll talk about pricing and give you those. Be able to help impart what I've learned over my 26 years for that work. So hopefully you will join us in a week.
All right. Well, let's get a warm congratulations, appreciation for Chris. Thank you very much, Chris. Looks like we had most of our questions actually that were posed during the presentation. So if there are any questions that are posed after the fact, we would love to be able to get back to you. It looks like there was one slide that we needed to update, so I'm going to update it as we're talking. But again, I just wanted to thank all of you folks that had joined us today for your contributions, for your time. There's a couple things I wanted to briefly just mention as we were talking about this wonderful content, and that is, as you are pursuing work, you obviously want to be able to provide a proposal that gives your customer the impression that you understand the scope. That's clear from the get-go. And I think what Chris and Dave have really brought to us is really given us an understanding of the elements that are not necessarily obvious when you're preparing a proposal. So whether we're pouring concrete or painting a wall, there are indirect activities that impact your cost. And if those aren't properly quantified, there's a good chance that you could be leaking profit. And so it's really important for you to quantify all of the activities on your project, direct and indirect. Think about, as Chris had mentioned, access. If you are performing activities or delivering work and there are other people involved in the area that you're working at, that can impact your productivity. Typically when you're involved in civil and structural work, you don't have the trades on top of each other like you do in architectural, which we'll be discussing next week. But there can